Hello community! Yes, this is the current status of RAG. And you remember RAG, our beautiful Retrieval Augmented Generation to enhance our language model by external information systems. And you might say, hey, never mind, because now we have RALM, our Retrieval Augmented Language Model system. Well, yes, I know it's a new rebranding here on November 15, 2023. Tensor here, this beautiful Chinese multimedia conglomerate, has here this publication. But you know, if you look at the abstract and you read here, hey, that RALM often struggle to assess whether they possess adequate knowledge, both on the intrinsic knowledge and on the retrieved knowledge side, to provide an accurate answer. And in situations where the knowledge is lacking, these systems do not behave in the way that you want them to behave, you understand there is something wrong. And if we follow the authors of these studies here and we look now here, that RALM suffers from several further limitations here. Risk of surface level processing, difficulty in handling contradictory information, reduced transparency, reduced interpretability, overdependence on retrieved arguments. And I'm running out of space here, but read this. This is really interesting. We come to one conclusion. Yes, this is the way it's gonna be. But you know what? Never mind. This is a positive video. This is a good video. So we have here the spark of hopefulness. So let's have a look at this system again. And I would like to show you something beautiful. Something wonderful is gonna happen. Okay, let us start with our LLM here. And we have a system borderline. Here our LLM ends, and here's an external system. Beautiful. Now you know this external borderline, for example, for OpenAI, they call it, hey, pay for every token that passes this borderline. And we have here channels that pass through, for example, with the help of an API call. And on the other side here, you have, my goodness, you have me sitting there as an intermediary just in this simplification. Don't be afraid. So a user has a question to an LLM, and the LLM decides it has not the internal knowledge. So it sends out a call and asks for help. And I'm here to help. And I have to find the answer to the question how to solve a quadratic equation. Now you know, I can do here a keyword search in the documents. I can call my grandpa, who is an expert on this. I can Google it. Or I can connect to a vector store and have here a similarity search operation and not a keyword search operation. And you know, we call this the good old RAG. This was in the good old times. Now, of course, if I'm an advanced programmer, I can code my own sentence transformer system. Or if I'm really excellent and I'm a subscriber to this channel, I watch here this video how to build a self-reflective self-RAG system, a multi-RAG system with some inherent logic and expert system. Or, hey, why not just ask another AI system like Google Bard? Maybe they have the solution. So you see, the choices where you try to get this external information are almost unlimited. But let's say I have found my solution. So now I write a prompt back to my little LLM. Let's call her Betty. And I write to Betty here my prompt with an in-context learning, an ICL. Or maybe you know there's few short examples. 1-2 examples I provide in my prompt to Betty. Or if you are more modern, we have here in-context prompting, ICP. All the same thing. So here is now, I asked ChatGPT to produce here the solution, the answer, and we have it here. So I can put this now here in my prompt to Betty. Great. Or I take the answer and put it in a PDF file and upload this PDF to my LLM, because we have the retrieval function now in our new OpenAI systems on our own. We can create GPT system. You might say, great. Or since we have code interpreter also with the OpenAI system, I take the answer, write a beautiful Python file, and upload the Python file to my Betty. Great. So you see, really easy done. Or I upload an image of the Python code to GPT-4 Vision, which is also integrated in the new OpenAI. So you see, the way I feed back a solution in a multimodal system is also almost unlimited. So there's no problem with this. We will focus here on two main systemic problems. We always have a limited token length, and we have the main problem of system coherence. Great. Now, let's have a look here detail at the first problem. You know, we have here our LLM with its internal knowledge. It has been pre-trained and fine-tuned on task, and it knows a lot of. And then we have the borderline to the external knowledge. And we have now an answer to our question. So we feed back now this external answer into our 128,000 token context length window. I call it an external knowledge window. So what we have the internal knowledge of our LLM, and we only have this little pipe here with a 128K context length, this external knowledge window that also belongs to our LLM. And you might say, hey, great. So now I take here the solution provided by our Retrieval Augmented Data. I feed it back in the system uses it, and it generates here a Retrieval Augmented Generative text. Beautiful. Now, let's feed this in. This is our in feed, if you want here. And this moves now into our LLM. Great. Now, if you have some conversation with your AI system, your packages move in, beautiful. And you remember, the yellow one is where I have the solution to a problem, how to solve a quadratic equation. And now it happens that having a conversation and having other topics and other problems and other maybe equations with different numerical values, this knowledge comes now to the end of my 128 context length or your 8K context length, whatever system you use. And now, please, careful. A lot of my comments say, hey, now this information now is fed into the LLM. And it becomes part of the LLM because it has entered here our external knowledge window. Now, this is not the case. In reality, what happens, it falls out here of our 128 context length window. Imagine it falls down and there's a black hole and it absorbs here the information, and the information learned is deleted. Is not anymore in our 128K context token length. So this means we lost now the ability to solve a quadratic equation because this knowledge was not integrated into our internal knowledge of our LLM. So you see, this is a problem, but you might say, hey, easy. When I know that I reach my 128K and there's the problem in the middle and everything else, but let's ignore this for a moment. I say, hey, if I want to keep this solution alive in my external knowledge window, when I know that it will fall out, I store it in my database. So you have a vector store and you pay for the vector store and for the token, and now you pay for the database. And in this database, I keep this solution. And I decide now that I will feed it back here in my external knowledge window. So in the knowledge of my LLM, here in the external knowledge, I have my corporate solution for corporate specific problems. For example, the first one is how to solve a quadratic equation. And every time it moves through and it falls out, it's feed back, and the database decides now it's time to feed it back in the loop. And you see what's happening next. We fill our 128 external knowledge pipeline with our handmade solution. And the next solution, 4, 5, and 6 are already waiting. So we fill up here our pipeline, which is not what we want. And the moment they leave the pipeline, the solutions are gone, forgotten. So what we do? What we do to solve this problem? Now it is easy. You go to my video where I compared here the developer day of OpenAI to this beautiful Microsoft GitHub presentation. And what you find there is Sam. Sam has today been fired by OpenAI. Is not anymore with OpenAI. And also the president of OpenAI has decided to be not anymore available for the leadership team. So the main two head of the company are not anymore with OpenAI starting today. But at the developer date, Sam told us, hey, we have new services. If you are rich, if you are a beautiful global corporation and you have the money, we offer you two solutions. We offer you GPT fine-tuning to bring those knowledge, your corporate knowledge, into your specific GPT 4, 5 fine-tuned LLM. Or, and I mean, if you're really wealthy, an ultra-wealthy corporation, you know, we're here for you, and we have custom models. And we not only fine-tune the custom models, but we do a domain-specific pre-training. My goodness, so these are millions and millions of dollars, and if OpenAI tells you it's not gonna be cheap, you know what this means. So, just a week ago, we found a solution what the companies are offering other companies to handle this problem. And of course, Microsoft here, the official solution here for its enterprise customer on GitHub, they would love to have the internal knowledge of their company in the Copilot. Please remember, the Copilot is not only the product of the Microsoft GitHub company. Copilot was rebranded 2 days ago for the whole Microsoft corporation, and not just includes here the GitHub Copilots, but every other Copilot. So Bing Chat and Bing Chat Enterprise is now also Copilot. So we have the perfect mix up here of marketing slangs, whatever. We are interested in the research solution. And Microsoft GitHub Copilot Enterprise offers now, starting in February 2024, a solution to enterprises, to wealthy enterprises. They will also fine-tune your models so you have your internal corporate knowledge in your Copilot, in your code LLM. So we see those companies, those global leaders, offer solution to enterprises who are able to pay for their services. What they achieve now on an enterprise level is they bring in all the 100 solutions that you need for your company that you have discovered in your particular enterprise. And they fine-tune your LLM here in the system of your LLM to directly integrate all the solutions into your internal AI knowledge. So what you have a personalized LLM, you have a corporate large language model that is now optimized for all of your tasks. And benefit is you have your complete external knowledge window free. So you can connect to the outside world, you can make here an API call, you can jump around with agents, whatever you like. You have cleaned up, you have opened up, you have freed all the resources here for access to external knowledge in a completely different way. Now, I told you we have two problems, and the second problem is more massive. We have a system coherence RAG problem. Now, one way to tackle this, yes, I promote here my own videos. You go to this video and I explain it to you on a quantum analogon level. Why Microsoft AutoGen RAG fails with multiple agents. Or we make it very simple like in this slide. Look, just to give you the idea, it is so easy. You have your LLM and this LLM has been pre-trained only on English text. And this is not just an idea. This really happens that some LLMs are only focused on one language only. And then from your Retrieval Augmented Dense Vector Store, this vector store returns the solution to the question you have, and it returns, let's say, French poetry. Now you immediately understand that you have here a problem, because if it was only trained on the English language, how should it understand French poetry? So this is not going to work. Whatever here our dense vector store returns, it will not be helpful, and there's no reply at all. There's no answer the system can process or understand. So you get no answer from the system. Now let's come a little bit closer. Let's say the same English LLM, and now we have here that the vector store, the retrieval augmented data return here gives you English medical terms, these Latin terms of all the different parts of your body. And if you have a look at those beautiful terms, you find they are completely incoherent, because this LLM has not been pre-trained on this time or this part of data sets. Incoherent. In my last two videos I showed you, I programmed my LLM here on 1 million APIs, and then I retrieved here from a vector store. And please, I don't care if your vector store or your vector embeddings are from OpenAI, if they are from Cohere, if you go to a commercial vector store, it doesn't matter at all. You have this system with all the different companies out there with vector stores and on. And now let's say those vector store returns here the new documentation of the new OpenAI Assistant API, like in the video I showed you in real time. And you know what I showed you? It is incoherent. The system, the LLM, cannot find a solution, because this new Assistant API documentation has so many more new terms, new primitives in its API, new combination in the API code that you write out here, for example, in Curl or in Python or whatever you have, that it cannot integrate this external knowledge to its internal knowledge. So we fail again here with RAG. This is the video that I told you where I show you this here in real time, and I also show you a solution to the second problem. In this video, and I get some replies from my viewers, they say, hey, can you explain this a little bit more? Of course. Here, this is our neural network. This is our own GPT that we built from OpenAI. You know, you can build now your own little GPT builder. It builds a GPT. And in the training data set, beautiful. For example, it was pre-trained on an API 2 documentation. Any API was trained on this documentation. Now, what we hope for is, if we bring in our retrieval augmented data with the new API, as I showed you in my video, and let's call this API 1. And let's imagine we have this in a vector space representation in the embedding. And you see here, our GPT has been pre-trained on this API 2, and we have here our nodes here in the neural network and our edges, beautiful. And then we bring in a new answer from RAG. And this answer is, for example, this dot here, a very specific answer. And if we're operating here in a vector space, we have a cosine similarity measure, topological space, everything I already explained to you in my last video. And you have now this situation. Now, give you a very simple example. Imagine my new GPT was trained on surveillance task. You have here the military operation coming up, and you have surveillance. And you have classical mode of surveillance. You can send in a team, you can listen to their communication, you can have a lot of different measures. And then the vector store gives you as an answer here a drone bag. Now, if our system, our LLM, has not been trained to understand about the functionalities and the possibilities, how you operate a drone, how you integrate a drone in your normal surveillance system, our LLM is unable to understand this vector space element that is now returned from RAG. Because our LLM has not been trained on what it is, how to use it, how to perform this thing. So we have here a semantic incompatibility in this very easy example. And now there's one hope. And now all the people believe there are emergent abilities of AI that our GPT system here in pink is able to say, hey, I learned so many surveillance techniques. I now, as an AI, I understand this. I have now developed emergent abilities. And we're not talking about general intelligence. We're just talking, hey, I studied here 500 different ways of surveillance, and now I can logically deduct how to operate a drone, how to integrate a drone in my tactics, in my surveillance strategies, how I operate it in the timely integration with other methods. So we are focused here on emergent abilities of AI. And now comes this study, September 2023, Technische Universität Darmstadt and the University of Bath, United Kingdom. And they say, hey, are those emergent abilities in our LLMs true? Do they exist? And this is a beautiful study, 50 pages. Please read each page carefully. Because they are looking here on these abilities of AI. And the term emergent abilities refers to the performance on tasks that they have not been explicitly trained on. And it suggests that the true emergence occurs when a model performs well on a task it has not been pre-trained or fine-tuned on. And this is different to all the pre-training and fine-tuning and everything we do with your in-context prompting and ICL. This is really, is the system able, if it has been pre-trained on method 1 or API 2, to deduct now, if given a new API, that this is almost the same system and it's able to make the connections. So the result of this study, after they did more than 1,000 tests, ChatGPT summarizes here 50 pages of this study, and it says, well, yeah, so the paper finds no evidence of the emergence of reasoning abilities in LLM. So the answer is more or less, the emergent abilities that we see is what we give the system with our few-shot examples, in-context learning, in-context prompting. But the system itself inherently is not able for those emergent abilities. So this is what you hope for when you bring in a vector store element or something that the system has not been pre-trained on. And you think, but it is so similar, it should understand. Well, now this study tells us this is an incoherent approach we cannot rely on. This does not guarantee us a result. So beautiful. And this is a rather devastating result. So we can confirm, RAG, thank you. It was beautiful the time with you. We learned a lot from you, but it's time to move on. And you know, now the positive thing is, hey, we learned so many beautiful, important facts from RAG and the failure of RAG. And I understand there are companies out there and startups invested hundreds of millions of dollars and they will continue, and this is beautiful. But we are here in AI research and not in AI commercialization. So for AI research, we go on. And in my last video here on the RAG GPT failure of OpenAI GPT systems, I indicated the solution to you. And this was the last slide of this video. And now we take it up and you know the solution already. I've given you the solution. You remember we had our GPT-4 or GPT-5, whatever you have, never mind. With our neural connectome, with the learned weight tensors. And I told you, hey, the solution will be here a fine-tuned hyperplane with the learned weight tensor manifolds that have been learning a very particular task. And you know, those are adapters, and we can stack the adapters, and we have the solution. And I told you there's a research by Stanford University, UC Berkeley, about the optimization. Now, to be a little bit more specific, that you get a feeling. So we have a huge base model, GPT-4, or choose whatever you like, with XYZ billion parameters. And now you know what is my adapter. And I showed you can either go with PEFT, the parameter efficient fine-tuning, so not RAG, but fine-tuning. So we bring the data into the weight modification. And I showed you one PEFT methodology, and I showed you LoRA and the quantized LoRA version in the video. And we had here about only 110 million parameters. This is a tiny, tiny fraction of our base model. And when we have adapter 1, we have adapter 2, and I showed you in the video how you can switch on and switch off adapters, activate adapters, integrate adapters in the inference. And if you want to have a deep dive, in the last 2 weeks I prepared this. There was this video that I showed you with RAG and PEFT. And then in this video, I explained here in detail a multi-LoRA adapter methodology given PEFT. Then I showed you that quantization of LoRA is not the latest research, but loft quantization is even better, has a higher performance. And then one of my last videos was here, RAG GPT failure. And now you say, and today we discuss here this missing piece. No, you already have it. Because in those 2 videos where we fine-tuned here a copilot, I have given you already the answer. Because in those 2 videos, in the first video I showed you the theory, and in the second video I give you the complete Python code, we trained here a CUDA 15B. And I've chosen here a Python optimized code LLM because a code is clear, a code is beautiful. If you have one character wrong in a Python code, it's not gonna work. If you have some French poetry and you have a word, well, you cannot really decide if it's the absolute correct word. But in a code, you can be absolutely sure either the system works or it does not work. So I went here with a code LLM to be here really transparent, and we immediately identified the problems. So we have here in those 2 videos, we coded here our 15 billion parameter model, and we did it with a PEFT, the fine-tuning with the low-rank adaptation methodology. And in addition, I showed you the quantized low-rank adaptation methodology, where we fine-tune an additional hyperplane, where it happened that we learned here the weight tensor manifolds on a particular task. And you know, this were only 0.1 billion parameters. So this was just a fraction of our base model, of our main model. So we have now this beautiful option not to fine-tune here the classical fine-tuning of StarCode, of our base model, again and again. And we have catastrophic forgetting and a lot of other effects. But adapters are a beautiful solution to fight this forgetting, because we still have here, with 15 billion parameters, our main base model. We do not alter the tensor weights. We just add, we inject here new tensor structures. I have a video here how LoRA works, how PEFT works. And we can do this here in multiple layers, in multiple blades that we switch in. And now, of course, computationally, we encounter a problem if you do more and more and more. My goodness, you need a very powerful compute infrastructure. And I showed you here in these 2 videos, StarCoder 15B. Then we chosen here OpenAI's Assistant API. And I've showed you here when we code here, when we extract from GitHub the top 10 Hugging Face repos. So everything about transformers, everything about diffusers, everything about here the other top 8 GitHub repos from Hugging Face. How we can code here how we can fine-tune how we can code the fine-tuning of our low-rank adaptation adapters on this. And how we can integrate multiple adapters, and I already showed you this. And now this is the reason why this video is so simple. because now we bring it all together and you immediately understand now the concept. Now the beauty is, if you have those little tiny planes with only 0.1 billion parameters, you can update this monthly. Whenever there's a new documentation on how to use the latest assistant API for system ABC, you just update this little thing monthly. You have your base model, then you have your parameter efficient fine-tuning, but you do not merge the weights, but you leave it here in this fine-tuned layer. So you have all the knowledge of the star coder, and the fine-tuning only happens for the particular task of learning the new assistant API notation, only happens in this layer. And if you say, hey, I want to be on top weekly, I want to fine-tune this adapter too, that I have the absolute latest and brightest documentation. I know everything that changed in the latest revision of code. You can update it weekly. Switch it out, update it. Takes about 10 hours for this adapter too. Switch it in. And the system, you can leave the other adapters unchanged, and you have this new knowledge transfer into here the weight structure of this adapter. To give you an idea, I use StarCoder 15b, and I trained this on OpenAI's assistant API documentation here on a pathed LoRA methodology here with those 0.1 billion parameters, and it cost me about $35. And I did not fully optimize it. So if you can do it, you can do it a little bit cheaper if you do it in a more clever way than I do it. If you do $35 monthly, you are so up to date. If you think about other commercial code LLMs that are updated every year or every 6 months, you can do this weekly or monthly. And it is about $35 for this particular configuration, for this particular size of the training data set, for this particular infrastructure. As I told you, switch out the blades, update it, switch it back in, and all the other system stays, and you have the optimal performance on this specific task. So now when you need this specific task, the latest assistant API from OpenAI, how to write code with this, you have it in your system and not RAG. Great. As I told you, there is this extreme complicated computation of so many layers of LoRA. It was a problem to compute this until we have UC Berkeley, Stanford University, and Shanghai Jiao Tong University. And November 7th, 2023, they presented us with some new compute optimization, scaling LoRA, something beautiful. Now, at the same time that they say, hey, we scale here for adapters, you see here, you know from which platform, Julian, co-founder and CTO at Hugging Face, tells us, hey, November 14th here, we say, hey, what is the AI equivalent for forking a repo? It is to fine-tune a model. And today, November 14, we introduce a new feature to Hugging Face. We now display which base model a given model is fine-tuned from, or is an adapter, is a LoRA adapter. Now, what a coincidence. Have you connected those two pieces? Because now you can see here, now you have here a listing of adapters for base models. Genius. But okay, let's go back to our original scaling LoRA. What they did, they optimized their computational performance, and they did it in 3 different ways. This is from the original Stanford publication. So what they did, they have now a unified memory pool for adapter weight tensors and our key value cache tensors. They minimized the latency when batching now those different LoRA adapters, and they developed a new maximum tuned tensor parallelization methodology when computing now the tensor multiplication between different LoRA adapters. Ben, for you, this is batching. This is unified paging based on the page attention. And this here, GPT-4, explains here the new tensor parallelism approach here for partitioning the base model tensor structure. If you read the original Scaling LoRA Adapter publication from Stanford and University of Berkeley, you find this way, this depiction, how they optimized the mathematical operation of multiplying matrices, multiplying tensors. And yes, this is a science in itself. How is the best way that you multiply one tensor with another tensor, and even if the tensors live in different layers, how you can have here the best efficient memory efficiency. Now, if you look at this layer, you understand this is just a a multi-layer perceptron, but we're gonna need this for the self-attention mechanism. So it took me 5 minutes to look at this and say, my goodness, how do we transfer this simple diagram of our multi-layer perceptron now to our self-attention mechanism? And then, here you see the solution. Okay, so if you read this study and you are into computer memory optimization management, this is for you. For all the normal human beings like I am, we just look at the performance. What we achieve with this new optimization technique. And Stanford tested this here on a Llama 30B model with 2 A100 NVIDIA GPUs and a configuration of 4 A100 40GB NVIDIA GPUs with 10 to 100 adapters, and the Llama 70B model with 2 and 4 A180 GB GPUs with 10 adapters. And I think 10 adapters is a reasonable amount of adapters. And I will show you what we can do with 10 adapters in a second. So they tested this out. Now, what is the result? I just want to give you here the improvement. So compared to what I do, I use here Hugging Face PEFT library. I use Hugging Face PEFT script and implementation here of the parameter efficient fine-tuning. And if you go now to the Scaling LoRA, and if you apply all the memory optimization and the CUDA kernel optimization here for your NVIDIA graphic card and your data center GPUs and, your improvement is multiplicative 30 times. And if you go to an already optimized LLM serving platform like vLLM, your easy, fast, and cheap LLM serving inference and serving for everyone. And they started in summer of this year. And now they have this vLLM, and I thought personally, hey, they are really fast. They are optimized exactly for LLM inference. And Scaling LoRA has a 400% performance increase over vLLM. This just shows you what you can do still in the optimization process of memory management, how you compute here your tensor multiplication operation, and how you shift it if you do multiple LoRA layers, adapters. And of course, S-LoRA also increased the number of served adapters by several orders of magnitude. So this result here is amazing. But remember, it does not happen overnight, because if you look here, Berkeley and Stanford also had a publication here on paged attention. Remember, this was the basis where they started for this new methodology. And this happened here beginning of September 2023. And now they outperformed even this paged attention 400% just 2 months later. So in AI, the optimization techniques are rushing by 400% throughput performance in just 2 months. Amazing. Yeah, key value cache optimization. So if you are into this, beautiful time to be alive. But of course, here we have the researcher, and this is, let me have an overload of archive papers I read currently. I think this is the University of Washington and the University of Denver. Anyway, another publication here, end of October 2023 here, multi-tenant LoRA serving. So you see, this is a hot topic that really a lot of publication happened today. And yeah, you have a new CUDA kernel design that allows here the batching of GPU operations for different LoRA models. And you see where all the research is heading for. Multiple different LoRA models, LoRA adapters, LoRa layer, LoRA optimization, and compute optimization. We need to get better, faster, and cheaper in computing those things, given we have an A100 NVIDIA GPU or an H100 80GB NVIDIA GPU. Great. From the Scaled LoRA publication, I had to smile when I saw who financed this study, who was gifting this study. Anyscale, Google, IBM, Intel, Lacework, Microsoft, Samsung, Uber, and VMware, and supported by the Stanford Center for Automated Reasoning. So you see, those companies somehow seem to be interested in those solutions, those new research solutions that are not yet in the commercial implementation phase. But those will supplement or substitute our current methodologies. So, if we have this, and this is now our new solution to the problems we encountered with all the RAG system and the RALM system and whatever you want to marketing term, slang, call it. Now we have a new paradigm. We have a smaller base model. I can tell you StarCoder 15b for my particular Python task. I took an Python optimized StarCoder, and the 15b was enough. I optimized this on my particular task that I wanted. My system is able. And I have only a Python system, so I have not 80 programming languages. No, this is a one computer language system only, but it is highly optimized for a particular task. And you know, going back here to open source and going to smaller models, we can build this. We can build it ourselves. And of course, if you have the financial resources, buy from Microsoft GitHub. Go and buy their enterprise solution, and where they have 80 or 120 computer languages. If you need this, everything for everybody in your company, there are those commercial solutions. But we also have open source solution for the normal human beings. Okay. Microsoft marketing. Yeah, Microsoft Ignite 2023 just happened for me days ago. And I had to smile because, you know, Microsoft introduced their Phi 2, a new base model that has only 2.7 billion parameters. And according to their marketing material, hey, demonstrate here, it's beautiful. It does everything. Common sense, logical reasoning, it's absolutely 2.7 billion, and yes. But you see the general trend. Smaller, more specialized models with a highly intelligent compute technology, with a highly optimized fine-tuning way with lowering adaptation or whatever you go, gives us adapters that we can train here singular on our specific task that we need as a coder or as a corporation. Now, Microsoft, of course, if you go there, yeah, and you know what? They tell here in the new Azure AI model catalog here, this Phi 2, with the right fine-tuning and the right customization, those small language models, smile, are incredible powerful tools for application, both on the cloud and on the edge. And according to Sebastian, who leads here the machine learning foundation team at Microsoft, Phi 2 from Microsoft is the perfect model to be fine-tuned by Microsoft on the Microsoft Azure platform, given to you by Microsoft. Now, great. I just have here one comment on this. whatever they tell you, and I've heard from the CEO of Microsoft that this is all open source, I went there, I read the legal fine print, and Phi 2 is not open source. You are not allowed to use Phi 2 for any commercial activity, not even in the slightest way. So whatever you are told by the marketing team, you always have to read the legal fine print if you're allowed to use this model or not. Great. So here we are. Here we are now on the positive side. We found a new solution. We have smaller base model and highly task-specific path LoRa adapters that do the job for us. It is not GPT-4, a monster, huge, humongous GPT that does everything for everybody. We have laser-focused systems developed. Now let me give you an example. We have here our pre-trained model, star coder, or you take an LLM, and then you have your LoRa adapter layers that have been fine-tuned. So you integrated now the external knowledge into the inherent knowledge base of your LLM. And one layer could be that you fine-tune here your corporate-specific repos. If you have some specific code, you fine-tune a layer for this. If you want to update here on the latest Hugging Face code, script, repos, you take the top 10 GitHub repos from Hugging Face on forever you would like to have integrated in your corporate knowledge base, and you have a LoRa blade here. If you want to integrate new libraries that came out last week here for your corporate task number 17, whatever it is, do it here with this path LoRa adapter integration. If you want to optimize for a new update from an API or whatever, or you want to learn here new code optimization techniques that in your corporation somebody found, make it available on your corporate LLM for everybody by simply fine-tuning here, not the complete system, but only a LoRa adapter. Or let's take here the language model. Let's say you are a company and you have 100 new products in your portfolio, and you have 100 new product descriptions available for each product. So you do not have to pre-train a complete model. You just take here a fine-tuned LoRa adapter layer, and on this new product, you just train this little layer here. Or if you want to update here on a current sale info, or you have special promotions this month or next month, you do not have to do the whole system. You do not have to bring in RAG. No. You just have here your beautiful LoRa adapter. If you want, for a chatbot with your custom optimization, you want to optimize now your system AI, your corporate AI here for cross-selling. You find here the best data set from your best sellers. You collect the data, how they approach a client, how they formulate this, how they have this tactic, their strategy to convince a customer for cross-selling. You take this data set and you do a fine-tuning of your LoRa adapter. Or you learn here corporate upselling tactics. Again, you have 2 or 3 maximum intelligent people who are excel here at selling new things, upselling here to their customers. Make their knowledge and the way they operate, their patterns of operation, their insights, what they learned, available to everybody. Make it available to the AI simply by using here the fine-tuned LoRa adapter. So you see, you can configure your perfect customer interface AI according to your needs, according to your product description, according to your special promotion you want to push in a month. You can optimize cross-selling, upselling, whatever you need. You can configure your system. Exchange a blade, put in another knowledge adapter, activate one, deactivate another if you want to have a special configuration. And you know, some of my viewers, some companies send me here offers that they receive here from the global, let's call them top 5 consultants corporation. And I have to tell you, when I see figures of $3.5 million for a prototype, for a commercial enterprise prototype, let me compare this to the real training cost. Where I say, if you have this, you could have every month a new optimized AI, exchanging the blade, for the training cost of this AI of, I think, about, this is a rough estimation of $500. And then you see offers here from 3.5 million US dollars starting for not operational system, for a demo. My goodness. So there is really, you know what there is? Yeah, there's, okay, vector stores on rack. We've checked this out. But what I want to show you here is, this is a move that I did not understand immediately. November 14, Hugging Face started to have all their models and all their adapters and all their fine-tuning and everything, how many 100,000 models they have, to sort this now for fine-tuned and adapters. And if you think about this a moment, you know, we have the App Store, and in every handy you have your App Store. Then OpenAI told us last week we have now the GPT store. And I don't know if Sam is fired and Brockman is gone too. I don't know if it will really be operational in the end of November. We will see what happens with OpenAI. I don't know this. But you know what is the next thing? The next thing is a fine-tuned LoRA Adapter store. Because there you choose the elements for your particular AI system. You choose blade number 2, 4, and 12 for a specific configuration of your AI system if you want to have it as a customer interface. Or if you're a coder, you go here for some fine-tuned LoRA adapter blade 312, 618, and if you need some special configuration, Hugging Face has the dataset for this. So Hugging Face started November 14 this year to provide you this information, and they build up now this fine-tuned LoRA adapter store, or in general adapter stores. And I think this is a brilliant move. They understood what's happening, and a lot of people just talk about the GPT store by OpenAI. But I think this is not a sustainable development. But I think this idea here, smaller base model, highly modular, highly flexible, cheap to implement, weekly updates, monthly fine-tuning. This, I personally will use here, really intensive. I will build here my very particular models, my specific models. So this is amazing. And also we started this YouTube video with a little bit on the dark side, what is not working. We learned from those mistakes. We learned from this development. And look at us today. Now we approached here a fine-tuning adapter store at Hugging Face, where we have all the adapters freely available for us. So, Hugging Face, what an intelligent move. So, close this video, close your computer, go out there, and it is a gold rush out there in AI. But just be aware where the AI research is heading for. So, have a beautiful life, get rich, get beautiful, get famous. Do not forget to help others and share your knowledge.